distinct objects in a row. Okay? So all different items. Right? So how do we teach this concept? We teach this concept based on the idea of the. Still remember what method? Still remember? I take the coin put inside the vending machine. Is the what method? Slotting. The slotting method. Okay, slotting method. So I permit 3 items, permutation of 3. What's the answer? 3? 3 factorial, right? 3 factorial. Okay, so if you forgot, look at the slashes. There are 3 different colors. How many ways can you arrange them? Total? 8. How many ways? 6, huh? 6 ways, huh? Okay, very good. Okay. So 3 times 2 times 1. Okay, total of 6 ways. Okay, 3 ways to go into the first slot, 2 ways into the second, 1 way to the last. This is what we did last time. After that, we were talking about permutation of R objects. Example, given 7 or 5 boys. Given 5 boys, I only choose 3 to be my husband. Okay? Given 5 codes, I only take 3. I only choose 3. And then the order matters. Or maybe I want to marry this one first, this one second, this one third. Okay, so the order matters. Okay? Then we did question 6, then 7. This is a repetition, remember? Repetition. Okay, then we did about 7 power 4. I took a yellow cone. Okay, so remember all this. Then 8, 9. So remember this? Remember this? I know it's been 1 week, but I hope you can recall. Yeah. So if I'm going to permute n, November, n items where n are identical. Okay, how we actually take the n factorial divided by the. So let's say if I have 3 identical objects, I divide by 3 factorial. Okay, can. So very quickly, how many codes do I have here? Okay, here I have 4 the same, right? 2, then 3 yellow, right? Oh, okay. So for this example, what's the answer? How many factorial? What's the numerator? Jack, numerator is what? Okay, stop thinking about other things. Focus. Jack, okay. 9 factorial over. Very good. 4 factorial. 3 factorial. 2 factorial. Right? Why 4 factorial? Because 4 items are the same. Why 3 factorial? 3 are the same. Identical. Why 2 factorial? 4 are the same. Yes, perhaps. A bit too long. Oh, wow. Yes. Sorry. No volume. Okay. Oh. Okay. I need to speak also, parent. Okay, so this is what we did last time. So if we have n items that are the same, basically we take them as a denominator and we divide by them. Okay? We are dividing the way the order created by the identical objects had they been distinct. Okay? Then after that we went to question 9. I went through question 9 with you, and then I give you some time to go through question 10. Okay, so I believe you have done it. I'm going to go through with you. Okay, so for question 10. Question 10, how many 8-letter code words can be formed from the letters of the word parallel? Okay, so you look at this now with an experienced pair of eyes. Okay, and you look at this, you know that are they distinct? No, right? Okay, so there are actually some items that are repeated. Okay, so when you see a letter, sometimes count also can count only. So what I advise is maybe you really just count the number of letters. So sincerely and honestly, I will do this. Okay, A got how many? A got how many A are there? 2. So I cancel. Example. How many L's are there? 3 are there. 1, 2, 3. How many P's are there? 1. Cancel 1. How many R's are there? Cancel 1. How many E are there? Cancel 1. Total you have 1, 2, 3, 8 letters, right? Okay. How many 8-letter codes can be found? A factorial divided by. Let me ask. Who can I ask? Can I ask? Fu Zhojun, Ricardo Fu. What's the denominator? 3 factorial. Over? 2 factorial. Okay. Okay, huh? So very good. I think all of you can understand. Okay, so 8 factorial over 3 factorial, 2 factorial. Why? Why 3 factorial, 2 factorial? Because 3 letters are repeated. So they are what I call the identical or non-distinct. 2 letters are repeated. Okay, so 2 letters are non-distinct. Okay, so the total number of ways will just be 8 factorial over 3 factorial, 2 factorial. Okay, why? Because there are 3 L's, there are 2 A's. Okay, answer comes out, you should have 33608 letter code words. Okay, children, can talk. Okay, then after that, question 11, I believe there are some blanks there for you to fill up. So I'll give you about maybe 3 minutes. It's very fast, 3 minutes. Just help me fill up question 11. Okay. Okay. Some of you are very concerned about the total number. You say, oh, 8. We're looking at the number 8. But actually, how many do we really need? We need the how many cones? We need how many tokens? 4, right? So what is the crucial number? The crucial number here should be 4. 4 is the number that we're looking at. Okay. So we need to consider cases, just like we did earlier. We consider cases. Okay, out of the 8, we are choosing 4. What kind of case can we get? Case number 1. Okay, let's say case number 1. I can have 3 blue and 1 red, right? So 3 blue, 1 red. Okay, now next part, they say arrange in a row. Okay, it's not just a choice, we are arranging in a row. Does the order matter? Yes, right? Okay, so 3 blue, 1 red. What's the answer? How many factorial? 4 factorial over 3 factorial, right? So, first one. 4 factorial over 3 factorial. Okay? Can see, right? It's not about the 8, it's about the number 4. Okay. Okay? Case 2. 2 blue, 2 red. 4 factorial. Hey, don't talk. Okay. 4 factorial over 2 factorial over 2 factorial. 2 are the same. Okay. Next one, what else? 1 blue, 3 red, right? Correct? Answer is also 4 factorial over 3 factorial. Can see, right? Easy, huh? Easy, okay. Last one, 4 red. 4 red. How many ways to choose 4 red? It's like 4 factorial over 4 factorial. Or actually just one way, right? How many ways can I choose 4 red? I can only one way, I can choose 4 red. There's only one way, correct? Which is all the 4 red. Okay, huh? Okay? So you can see that what we do is we focus on the number of cases. Okay, we focus on the number of cases. Okay, we focus on the number of cases. Okay, we fix the number of possibilities by considering cases. Okay, not so much worried about the total number of 8. Okay, like total we have 8 codes, but tokens. But we look at the possibilities that we can have. Number 1, we can have 3 red, or 3 red and 1 blue. We can have 1 blue, 3 red. We can have 4 blue. We consider total. We see that by exhaustion, you think through, there's actually 4 possibilities or 4 cases. In these 4 cases, what are the number of ways in which we can arrange them? Okay? Okay so far? Yes, follow me? Yes, okay. So total 4, 6, 4, 1. You will have a total of 15 ways. Okay, here, do we multiply them? No, right? Can they happen at the same time? Can I take 4 blue and 3 blue, 1 red at the same time? So the cases cannot happen at the same time. So which principle do we use? We use the addition principle. We are considering all the possibilities. Okay? That's for question 11. Okay? So permutation with restrictions. Okay, we always key guideline. This is not in your lecture question, just to tell you. We always deal with the restrictions first. Okay, we always deal with the restriction first before we consider the rest. Okay, so sometimes they may ask you, okay, maybe the first seed must be a girl. I want to impose a condition, first seed must be a boy. I want to impose a condition, first letter must be a vowel. Okay, all sorts of questions, all sorts of conditions. what you always do is, first come, first serve. Condition come, deal with the condition first. Okay? Think about the condition. How does it affect your number of outcomes? Clear? Okay, back row don't talk, back row. Okay, so next one. Question 12. How many different ways can the letters of independent be arranged in a row such that the first letter is a vowel? Okay, what is vowel? My English is not very good, but I think it's A, E, I, O, U, right? E-L-U, correct? So vowel versus consonant. Okay, so this is a vowel. Alright, how many different ways can the letters be arranged in a row such that the first letter is a vowel? Okay, so how many letters do we have? Total how many? Count for me. How many do we have? Okay, let's see. Same, I got how many? I got 1 and 3. D 2, E 3, P 1, P 1. Okay, so it always helps if you are having this kind of letters question. Go and count the number of letters because it makes a difference to your answer. Yes, okay, it makes a difference to your answer. Okay, so here, what are the cases? If the first letter must be a vowel, okay, what are the vowels we have here? Independent. They are I and E, correct? So considering the first case, if the first letter is I, okay, total 11 letters, I take away I, right? What do I have left? If I take away I, so suppose you see, I take away I. Okay, I take away I. I can say I take away I. I have 3 N, 2 Ds, 3 Es, 1 P, and 1 T, right? Correct? Total, if I take away I, so this means I'm doing this, Okay, guys, look here, okay. Case 1 looks like that. Imagine you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then, my first letter must be I. Over here, I have 10 slots. Okay, I have 10 slots. Okay, how many can we? So it's 10 factorial over 3 factorial because 3 identical letters, right? 3n over 2 factorial over 3 factorial, right? So this 3 factorial comes from the fact that you have 3 n's. This comes from the fact that you have 2 d's. This comes from the fact that you have 3 e's. Okay, this comes from the fact that you are so-called arranging total of 10 letters. Okay so far? Okay so far? Arranging 10 letters or permuting 10 letters out of which I have different groups of letters that are the same. Okay? Key thing is to what you do, count the number of letters. You need to know how many N I have, how many D I have. Are there any repeated letters? Okay? This is case 1. Okay, no one is copying. So I erase, we can erase. Can I erase? 1, 2, 3, erase. Okay, case 2, first letter, if not I, can be E, right? Right? Can it be A or O or U? No, right? Do we have A or U? O, U, don't have, right? Okay, so again, same thing, you consider first letter has to be E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 11 letters. 11 letters, I take away 1 E. I tell you, I want the E now. This E I take away. How many E I left? E I left with? 2, right? 2. Now we look at the repeating, the repetition. How many letters am I arranging here? How many? Thank you. Yeah, just answer me. I mean, just throw your answer. Can shout it. Then 10 factorial, right? So 10. Sorry, not 10 factorial. I should say 10 slots. We are looking at 10 slots, right? Out of these 10 slots, arranging these 10 letters, we have 3 N's, right? Okay, because of 3 N's. We have 2 D's. 2 D's. Okay, here, what do we have? Where does the last 2 come from? We have 2 E's. Alright? And that's why our final answer comes out to be 151200. Because 10 factorial divided by the 3 factorial, 2 factorial, 2 factorial. How do I get the denominator? By considering the groups of identical letters that I have. Okay? Can hold. Okay, with that, No one copy me, okay. Because you all heard me. Okay, so here again, can the two cases happen at the same time? No, right? Because some of you think, hey, should I multiply or should I add? If I multiply, it's like stage 1, stage 2, alright? But cases, can they happen at the same time? No, right? So what do? We add. We add the total number of possibilities. Case 1, case 2. We add them together. Okay, then that will give us the final answer. Okay? Which is 201600. Okay? Wow, suddenly very quiet. Okay, take a while, look at question 13. Okay, so total, I have 7 slots. Okay, I have 7 slots. We always deal with the restriction first. I go to the first slot. How many boys can I put? How many choices? 4, I put 1. I go to the last slot. How many choices? 3. So you see 4 times 3. Can you see? You are always using the slotting method. You consider how many possibilities can I put here? How many possibilities can I put here? Okay? Okay, right. After that, in between, left with how many slots? 5. 2 boys, then 3 girls, correct? 3 girls, correct? How many ways to arrange? How many ways to arrange? 5 factorial, right? So you can see, that's why you see, usually first one, you can see, first and last place can be filled in 12 ways. 4 choices for the first slot, 3 choices for the last slot. In between, there are a total of 5. Note that people are distinct. So we are actually 5 ways, 4 ways, 3 ways, 2 ways, 1 way. So we are looking at the remaining 5 people can be arranged in 5 factorial ways. Okay, so it's 12 times 5 factorial. Okay? I'll talk about this later on. Okay, this is the permutation definition. I'll talk about this later on. Okay? So some of the faster ones you're actually looking at for permute 2. If you don't know what this is, okay. Okay, don't have to know yet. Okay, I'll go through this on Thursday. Alright? So some of you are looking at this. Maybe the stronger ones will have read till the end of the notes. Okay? I'll talk about this later on. Okay, that's for part 2. Part 3. Okay, if all the girls are to be separated. Okay, so there are a lot of ways you can think about it. Okay, let's think of maybe the slotting method. Okay, 4 boys again. Okay, if I want the girls to be separated, there must be at least 1 boy in between, right? Means like this, or like this, or like this, right? Right? Girls are girls, boys. Okay? Girls, boys. Okay? Boys are the pointy ones are the boys. The girls must be separated, correct? Okay, so look at the girls that you have. How many choices can I take? 1, 2, 3, 4, 5. Slot. Okay, so 5 out of these 5 slots, I am taking how many slots? 3 slots, right? Oh, the girl commit no. Okay, okay. So out of the 5, I take 3 slots, right? Within these 3, does the order matter? Is this the same as this? No. So order matters, right? Order matter. Okay, the order matters. Okay, so the order matters, right? Okay, so you think about it, out of the 5, we are permuting 3 slots. Okay, so look at this. Okay, the boys, this one is your cones. 1, 2, 3, 4, 5. Okay, we can say that we are actually taking out of the 5, we are taking 3 slots, or if you're not comfortable with this, let's not look at this way. Let's look at it as 1, 2, 3, 4, 5, right? Okay, out of 5, I take how many ways? Okay, I have 5 items. Okay, I have 5 items. Yeah, I have 5 items. Let's say I don't use this, right? I have 5 items. How many ways to enter the first slot? Total got 5, right? How many ways to enter the second slot? 4. How many ways to enter the third slot? 3. Remember, permuting R objects, taking R objects from n distinct items, right? So this can also be 5 times 4 times 3. At this point in time, I'm not going to cover the permuting yet. So this is 60 or so, okay? Okay? Also, on top of that, if you see this 4 factorial, okay, can you understand the 4 factorial? Because the boys can also rearrange themselves, correct? The boys can also rearrange themselves. So total 4 factorial multiplied by 60. Okay, so it's multiply, not add. Okay, because can you think about it? Can they happen at the same time? So this one should be times or plus? Times, okay? Okay? Then, okay, let me go to question. Okay, if all the girls are to be separated, if all the girls are to be separated, okay, this one is, oh sorry, I've gone through this already, okay, I've gone through this already, okay, number 4, okay, if not all the 3 girls are together, okay, how can we go about doing this? What we can do is, okay, if you think the contrast or you think the opposite, if not all the 3 girls are together, what is the opposite? If I were to define this sentence, how will I say the opposite? Means I want all the 3 girls to be together, right? So if I think the opposite of this, or I mean like the contrast of this, we want the opposite of this example, opposite. Okay, let's say we're showing this opposite, okay? Okay, we can take, okay, the total number of ways. The total number of ways we can arrange the 7 of them, subtract the number of ways in which the 3 girls, okay, are together. Okay, so I look at this again. If I want the opposite of this, I can say, okay, for any arrangement, either all the 3 girls are together or they are not. Okay, so if I want this answer, right, what I can do, I can take the total number of ways for all 7 of them, okay, which is 7 factorial, correct? 7 factorial minus the number of ways in which they are together. Okay, and the number of ways in which they are together actually is none other than your part 1. Right? It's none other than part 1. So part 1 answer is 720. So you can just take 7 factorial minus 720. Okay? So part 1 means I'm taking total number of ways, subtract number of ways where all 3 girls are together. Okay? This is the answer for part 4. Okay, ma? Yeah. If I don't want all the girls to be together at the same time, it's the same as I take the total number of ways minus the number of ways in which they are together. Is it okay? So I'm thinking of the complement. Okay? We talk about the slotting method. This method is called the complement method. Okay, so it's another strategy that you can use. This is called the complement method. This is called the complement method. If I want to find this, how to find? I can take everything minus the complement. Okay, and then I can get the answer for this. Okay? So this answer here, this one is 7 factorial. This answer here, this is just your part 1 answer. Okay? This is for question 13. Still okay? Don't sleep, don't sleep, okay. If you sleep, slap your friend, okay? Sorry, if you sleep, ask your friend to slap you. Okay. Wrong way, okay. Question 14. Okay, question 14. Question 14. Listen, okay. Question 14, I know the answers already there, so I won't, it's like those PSLE kind of questions, so I'm not going to go into very, I think it's a very fun, it's like counting ball, you can just count it, okay? Sorry, how? Okay. Okay, so first one. Find the number of 3-digit integers lying between 199 inclusive, which have only only, cannot be 3, only 2, not 3. 2 consecutive identical digits. 2 consecutive identical digits. Okay? So, what we can do again, we consider cases. Case 1 is that your so-called second, third slot are the same integer. Okay? Meaning we can have something like this. We can have 0, 0, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Total, how many possibilities? How many? Okay, let's look at this. Okay. For the second and third, if I want, okay, case 1, you follow me, don't chat with your friend, okay. For second and third slot, case 1, let's consider one case. Okay, we're going to look at, let me go back to the start. Find the number of 3-digit integers, 3 digit, one, first, second, third. We look at, again, we try to sorting method. Lying between 100 and 999 inclusive, which has only 2 consecutive identical digits. First case, I can do this. It can be the 2 same digits are here, right? Second and third slot, correct? Of course, I can also say the second and third slot can be here. Am I right? You're right. So there are 2 cases. Okay, so in your answers you saw case 1. The 2 identical digits are in the first, in the second and the third slot. Okay? The first slot, right? Okay, let's look at the first slot first. What can we put in the first slot? Can we put 0? Cannot, right? So here you think about it. How many choices do I have? 9 choices, right? So first slot I have 9 choices, right? Correct? Second and third slot, remember I want them to be the same. So it can be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. How many choices do I have? Total of 10. Very good. Over here, I have 10 choices, right? Okay, from 0 to 9. But if you think about it, okay, so it looks as though it's like 9 times 10, right? Looks like it's 9 times 10, right? Okay, but is it really 9 times 10? If we were to do this, what are we counting also? We are counting the cases where we have, example, 0, 0, 0. Am I right? Where we have 3 digits to be the same, right? Do we want this digit? Do we want 3? We don't want, right? Because question tells you we only want 2 consecutive identical digits. Okay? So, okay, I'm just helping you to explain your solution. Okay, of course, there's more than one way to do it, right? Okay, so here you have 9 times 10, total of 90, but you need to exclude the cases of 111, 222, 333, all the way to 999. Total of 9 cases. That's why you have 90 minus 9. Okay, total of first choice, you have 9 cases. This one, over here, you have 10 choices, but you need to subtract away 111, 222. Total, subtract away 9. That's why it's 90 minus 9. Okay, I hope I didn't confuse you. Okay, stay close, okay? That's for the first case. And if you think about it, the second case is actually quite similar. Okay, second case, That means second case, if I do not want the digits to be in the second and third, it can mean I want the same digits to be in the first and second slot. Okay? Again, how many choices do I have? How many choices do I have? Can I put 0, 0 here? No, okay. So how many choices do I have? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Total? 9. You don't like all. Is it Jamie Pang? Is it? Oh, okay, no. Okay, so you have total of 9 choices. Total of 9 choices. Okay? How about the last one? How many choices do I have? I can put 10 numbers, right? 0, 1, 2, 3, 4, 5, 7, 9. Same. I can put 10 numbers, so I can have 10 choices. Right? But if you do this, you will also include the case of 111, 222, 333. Okay, because if I have x is possible. Let's say if I want, I choose 1, 1. Out of 10 choices, this can also be 1, right? So we need to erase away all the cases where you have 3 consecutive numbers. Okay? So for that, right, you have 90 minus 9. You have 90 minus 9. That's why you have 90 minus 9. Okay? I say again, 1, 2, 3. Here, I want first and second to be the same. I will have 9 choices. 9 choices. Here, I have 0 to 9. I have 10 choices. Okay? Then you subtract away the cases where you have 3 consecutive digits. So 9 times 10, 90. Here, 9 cases. 90 minus 9. 90 minus 9. You get 81. Okay? That's for case 2. So all in all, by addition principle, case 1 and case 2 cannot happen at the same time. Therefore, you have 81 plus 81 to be 162. Okay? I'll give you a while to digest this. Maybe 2 minutes, just talk to your friend beside you. Okay, if you don't understand, go and find someone who you think understands. Okay? Just chit chat with them for 2 minutes. Okay, now this is the time for you to talk. But don't talk about other things. Okay, see? 3 times 2 times 1. This is if it's in a row. But if in a circle, right? Let's say if I were to commute objects in a circle. How many ways do I have? It's actually 2. How to get a 2? In general, the formula is actually 3 is like 3 factorial divided by 3. Okay, why? Because of the first and the last. The first and the last, when we swap, okay, it actually changes. Okay? So in general, let's say you have to commute n objects in a circle. The formula is n. Actually, you can say it's n factorial over n, or you can say it's n minus 1 factorial. Okay? Either one is the same. N minus 1 factorial. Okay? I will stop here, then Thursday I will continue. Thank you for your kind attention. Thank you.